Seems to be working. Hi all. Thanks for coming. Welcome to Build. Hope you guys are having a good time. My name is Amit Chhitre. I'm a program manager in the Windows graphics team in Microsoft, working on the driver model and other projects like system on chip devices. Roger here is going to accompany me, and we have other members of our engineering team here today, and we can help you answer any questions after the presentation is over. Let's see. So today I'm going to talk about the graphics driver model, or WDDM as we call it, or Windows Display Driver Model. My key goal for the next 1 hour is really to talk about the several experiences and innovations we've enabled in the graphics driver model in Windows 8. We talk about these in 3 areas, one being enhanced end user experiences. There's some experiences which are new and have been introduced in Windows 8. Some of them are improvements which we made in the graphics stack, which just enables a better experience for applications and the graphics drivers. And there are system reliability improvements, given the fact that the graphics driver model is going to be highly dependent on, as you heard in the keynotes, everything, the Metro style applications, the UI is all hardware accelerated. The key takeaways at the end of the talk should really be, I hope you have a thorough understanding of the graphics driver model, or WDDM, in Windows 8, and learn about some of the experiences and improvements we made in WDDM for Windows 8, and what the impact is for applications, what the impact is for the drivers, and if you're a system manufacturer, what the impact is there for you. So in the keynotes all day you heard Windows 8 really is about reimagining the PC. A lot of things have changed, and while the existing ways of interacting with the interacting and using the PC are still there for you as before, we've enabled several new graphics experiences which are optimized for touch and new form factors. So I'll talk over these in the next 45 minutes or an hour or so. So let's start with a quick recap of the graphics driver model and what are the overall changes what we have done in Windows 8. So as you see in the first line, it says single graphics driver model for all Windows users. If you were there 3 years ago around same time for my Windows 7 talk on WDDM, you might remember that we said we are planning on deprecating the XPDM driver model, or XT, Windows 2000/XP display driver model. So we went ahead and did that. Not only is it deprecated, but the code actually has been removed from the operating system. So there's only one driver model in Windows 8, and that's just WDDM. And the driver model, the WDDM, is the one which will really enable all the Metro style experiences. That's where all our investments are going moving forward. So we enable all these new scenarios, new visual scenarios, new compute scenarios, and overall enabling Metro style applications and the UI. So in Windows 7, if you remember, you had a lot of applications were still GDI. There were a bunch of DX applications, but overall in the past, right, prior to Windows 8, the GPU horsepower was mostly utilized by game developers, by game engine developers, people who really knew how to who really wanted the GPU horsepower for their applications. Most of them were games, and there were some scientific applications. So like a small community of people really were writing DX applications. Windows 7 we introduced D2D, and there were we started the wave of 2D hardware accelerated applications using Direct2D and Direct Write. But there was still a small community of people who were using DX. And as you can see in the diagram here, right, there were GDI applications which were very dominant, of course, which still are. And even our Windows 7 shell was mostly a GDI client. So there was limited hardware acceleration, but it was mostly in the form of 2D operations like Blit and others. In Windows 8, the pictures changed, right? You saw in the keynotes, it was mentioned in the keynotes. Mike Angelo said it in his hardware keynote. Pretty much the Windows 8 shell and all Metro style applications will benefit from 3D GPU hardware acceleration. So what we've done is we made the power of the GPU available to any mainstream, any casual developer who will be developing like Metro style applications for Windows 8. So it's there for you in an easy fashion. You don't need to be a game engine developer to exploit the GPU horsepower, right? So as long as you are using the interfaces which were highlighted in the talks yesterday, you should have the power of the GPU at your disposal in your Metro style application. So that really is the key here. And what we've done is we worked with our ecosystem engagement team. They've reached out to potential partners, and we're working to make sure we have a good, reliable experience with the drivers and the graphics stack overall for Windows 8, so that your application just rocks on Windows 8. Again, a little bit of recap regarding the driver model. If you remember, in Windows Vista, we had that's when we really introduced WDDM, right? So that was V1 version 1 is what we called it then, and that enabled experiences like Aero glass colorization, and the window animations which were there back then. In Windows 7, we implemented the driver model to what we called WDDM 1.1, and there we did a lot of work, if you remember, for performance, optimizing the performance of the system for applications mostly which were using system memory, right? So we reduced the memory footprint of a number of applications, both GDI and DX, in the case where there were multiple windows open. So we did a lot of work there. There was also work done towards the display projection experience. That's when we introduced WinP, and there's a consistent experience across all mobile form factors, so you could go to any projector, just do WinP, do extended and clone mode. So those were really the two key enhancements which we did in 1.1 in Windows 7. Windows 8, we are incrementing the driver model. This is what we call WDDM 1.2. This is actually an excellent white paper which we have made available for you. You can download it. Should be live on Microsoft.com, where all the SDK documentation is, and that really highlights all these features which are listed here in way more detail. I'll go over some of them here, but it's not a complete exhaustive list, is all I wanted to let you know. The white paper has the complete exhaustive list of the driver model and what the implications are depending on what driver you're trying to write. So one of the key, we break it down into three categories. First one, say, enhance end user experiences. So we introduced new visual experiences, Stereo 3D, which we thought is really cool. So we went and did some cool stuff, Stereo 3D, so people can write nice Metro style applications which do stereo stuff. You can do Stereo 3D games or Stereo 3D video playback applications to watch stereo content. Another one, given the fact that a lot of the mobile form factors such as tablets are growing very popular, we did work in the guts of the graphics stack to smoothen out the rotation, screen rotation experience. So you guys probably already have all the Nikes here, and I'm sure as soon as you got it, you started rotating. So so we did work there to smoothen the experience out. Talk a little bit more in detail in the following slides. Then we did some work for boot and resume and smoothen the experience there too. Reduced some screen flickers and made it really smooth. Like the keywords since yesterday, like fast and fluid. So that's really been the driving. It's really been the driving, keywords for most of these improvements which we have made. And again, as you can see, like the maximum number of work actually is in the performance in the middle stack there. A lot of work really went into the things like enabling GPU preemption for better touch responsiveness, better desktop responsiveness. There were again sleep and resume optimizations, right, for these new form factors. You want to switch it on, it needs to come on instantaneously, and again going to sleep, come out of sleep. So we did optimizations there. We introduced new video memory utilization API and DDI. Given the fact that a lot of the applications are going to be using GPU horsepower, so we did some work there. Then power management, that's one of the most critical aspects here in Windows 8, and there are a number of talks which we'll hear in the next 2 days. Probably saw the keynote demo where they did the idle power demo. So there's work there, and I'll talk about it in a little bit more detail. And as you already know, we are there's system-on-chip devices, and there's new architectures like ARM hardware. So we did work there so that your Metro applications will like sizzle on these new form factors and these new architectures, new GPU architectures like tile-based rendering also. Then improved reliability. As you can imagine, like since everything's going to be using the GPU, we absolutely have to do and make sure, again, to make sure that the reliability of the graphics platform as a whole is rock solid, right? And it's not only us, it's you, the application developer, it's you, the driver developer, and it's you, the system manufacturer. All of us really need to collaborate here and make sure, applications, drivers, and the platform as a whole is rock solid. So we did a bunch of work there. We'll go over it, and we'll show the impact to applications which will be running on the GPU. And we added new diagnostics. We made available new tools and additional and better guidance for if you're a system developer or a system manufacturer as to how when you're designing your system, Windows 8 system, so you can use these tools. Should be available to you, if not through the WDK and other mechanisms, Windows Hardware Certification Kit. So let's start with the enhanced end user experiences. So I mean, this just boot. Let's start with something really fundamental, right? You get a PC. Like Mike Angelo said yesterday, like one of the things he showed was like he switches it on, and boom, it just like boots on. There's no flickers. And it just it's like a really fast and fluid, seamless experience when you get to the login screen. So shown here really is the Windows 7 experience here for boot and driver upgrade, for example. So what we had when you switched on the PC in Windows 7, you had the firmware, and when the firmware handed out the frame buffer to the graphics stack, there was a screen flicker there. And when the graphics stack and the graphics driver were loaded just before the login screen, there was another screen flicker. Similar for driver upgrade. Say you have a driver A, that's your current graphics driver. A new driver becomes available on Windows Update, for example. You download the driver. There's like a screen flicker for like a second or fraction of a second. Your screen goes black, and then you get the Windows VGA driver, and then it starts installing the new driver B, and there's another screen flicker there. And in certain cases, what happens also is your icons get repositioned because the VGA driver goes to a smaller resolution, right? So there were a bunch of screen flickers there. We did work in really the guts of the operating system and smoothened these transitions out to a really smooth experience. Gone were the flickers. You should see a nice seamless boot from the firmware to the graphics stack and to the login screen, right? And that this really coupled with all the improvements made in the kernel teams made several improvements to reduce the time to boot. So that should be a nice, fast, and smooth experience to the user's desktop for the end user. So here, really, the call for driver writers and actually system manufacturers is to make sure, when you are building Windows 8 systems, you verify the scenarios, and the expectations are as such, which I've shown, and the transitions are smooth. And we've made available several tools, from our team and several other teams in the certification kit and other kits, which will help you to measure these metrics. So make sure you use those tools, and make sure the experience is as smooth as possible for our end users, customers. So stereo 3D. So like I said, this is one of the cool things we thought we would do. I loved watching Avatar. I'm sure a lot of you did, and there's a lot of other movies also coming on. So it's like exciting time again for stereo 3D. So we worked again with our partners and ecosystem team, and made available stereo 3D experiences for gaming and video playback. So what we've done really is made available a consistent API and DDI across any platform. So irrespective of the GPU you are using, irrespective of the target game or target platform you're trying to write, there's a single API and single DDI which should. So if you're a game developer, for example, writing a stereo 3D game, and you're using our stereo API, it should work across any GPU, right? That was really the goal, consistent API and DDI. There are solutions out there in the market which which could be proprietary, but our goal really was to make sure a single API and DDI is there for you to write Metro-style stereo 3D games or video applications, right? So as seen here, our display technology display stack is flexible enough, and we really enable. We want to enable system manufacturers, builders, to really choose the display technology. Could be active shutter 120, could be active shutter on HDMI 1.4. So you are really enabled to choose the best display technology for stereo 3D and add differentiation and add value in the best way you seem is appropriate for your platform. It's seen here in the bottom right hand corner. The way quickly at a very high level it works is you have a 1.2 driver. As long as it's attached to a stereo 3D display, the driver will see the stereo 3D modes, and we enable stereo 3D on the desktop and in Windows 8 for you to use. And so, for example, if the user launches a stereo 3D application, he should just automatically start seeing a stereo 3D experience in Windows 8. So what we've also done is there's a user setting in the display applet which you'll see only if you have a stereo 3D display. So user actually can enable or disable the stereo 3D experience if they choose to. We also have a demo in the booth it's platform booth number 2 on the floor in the expo hall. So there's a really neat very simple stereo 3D game demo, and in fact the source code should be available to you. It's in the SDK. So it's a really simple game which shows you how to use stereo swap chains to write a stereo 3D game, right? And it's a Metro style application. So you can use that as a starting point if you're trying to write stereo 3D games or any other stereo 3D application. Smooth screen rotation. So like I said, bunch of you, all of you actually got your Nike tab, and I'm sure you played around with it. One of the things I do commonly is I take a tablet and I'm reading news, just reading news, going through it, and most news articles are not only text nowadays. There's like rich videos embedded in it. So once in a while I'll go, or in like Facebook for example, I'll go, hey, there's a video posted by my friend. I'll click on the video, it goes full screen, and then immediately I want to rotate the tablet and watch it in like a different orientation, say landscape now, right? So I mean, most content nowadays is so rich. There's videos and text in it, and basically the thing is, you need an experience which enables the end user to switch between the orientations fast and seamlessly, right? Earlier in Windows 7, there used to be a screen flicker going from portrait to landscape, right? Because of the mode change. So what we've done is again done work in the graphics stack to smoothen that transition out and made it really smooth. In fact, there is also no work for the graphics developer as long as you're using the WDM DDI. So it's all there for you for the application developer, and you can see like, oh sorry, I pressed the wrong button. See a smooth experience for rotation again. Sorry, in this case. So there is also a rotation. There's a sample, in fact, a Metro style application sample code, which shows how to use the rotation notification API if you're writing an Metro style application which needs to listen to rotation notification and is dependent on the rotation, on the orientation of the screen. So there's a sample, in fact, written by my colleague here. It should be there in the SDK, and which is available for download to you guys. And go through that and see. It's very simple, but shows how to use the new WinRT, the new Windows rotation API in your application. Also, another point I want to make sure, as I'm sure there's a number of system manufacturers and builders in you, once the kit Windows hardware certification kit is available, there will be tests, there will be metrics which will enable you to provide a great experience. So use the kit, and make sure you're using the tests and using the performance tools like Xperf and others to track rotation and make sure there's a great experience when you ship Windows 8 systems, especially tablets and other form factors which change orientation of the screen. All right, so let's move on to the performance. And like you saw in the first slide, bulk of our work really went into performance improvements. So let's start with a really simple one, like sleep and resume optimizations. This one really, we did work here for integrated GPUs. There's a lot of integrated GPUs in the market with the new form factors. A lot of them, in fact, are integrated again. So I go to meetings, I carry my laptop, and most of the time I'm running really late to the meetings. And as soon as I'm there, I just want to open my lid and start typing on notes, right? Everyone wants a really fast sleep and resume optimization, sleep and resume experience. Sorry. So every Windows release we strive really hard to make some optimizations, and most of these optimizations are really again in the core kernel of the graphics stack. So what we did this time is we made some optimizations in the video memory manager, really in the guts of the video memory manager here, and we eliminated a copy in the case of integrated GPUs. So as you see here, for integrated, it's really all system RAM, right? There's no dedicated graphics or dedicated GPU memory as such. The part of the system RAM is really used for video memory. So what was happening before in prior operating system was you had video memory, it was being used, it was in a portion of the system RAM as such, and then when the system went to sleep, we copied that part of the video memory into system memory. So what we've done is we changed parts of the video memory manager and eliminated that copy. So really what happens when you eliminate a copy, every time you eliminate a copy, you reduce the time to go to sleep and resume back, right? Because the copy operation takes some time, it's a fraction of a second, some milliseconds, really depends on how much video memory is populated in the system RAM, how much of it is being used, right? So the more of it is being used, the more time it's going to take, the higher the latency. So this really helps, to speed up for integrated GPUs the time to go into sleep and come back and resume. So we did also improve desktop and touch responsiveness. So this is really what we also refer to as GPU preemption feature. This was a key investment for us because again, this was a great collaborative effort between our partners through the engagement team, and we worked with them to understand GPU hardware, and we did work to make sure really the desktop and touch responsiveness is great. So the scenario here is really simple, right? I have a tablet again. Let's take a tablet because everyone's got a new tablet now. So I take a tablet. I'm reading a news article. Right, so I'm reading a news article, and I progress down the article, and I'm reading further, and I'm just scrolling, right? And I keep scrolling and scrolling, and what you really want, like Jensen said yesterday, things really need to come smoothly, flow in smoothly, and flow out smoothly, right? You don't want stutter in between anywhere, right? You're scrolling through the article, you want it fast and fluid and as smooth as silk as possible, right? So it just needs to be really smooth. So that's really the goal here. So say for example, my example of say scrolling here, what happens when you are really scrolling through say IE10 for example. there's two operations which are happening at the same time. One of them is rendering. You're just simply rendering the content as it comes available on the screen, and the second one is that of scrolling, right? So there's two operations here. So let's say these are application A and application B, just for the purpose of discussion here. So shown here in application A, that's really the workload of an application, and the unit of workload in our technical terms in WDDM is what we call a DMA buffer, right? A DMA buffer, so this is the blue box here for application A. This is the second DMA buffer right here. A DMA buffer further comprises of several primitives. Say DMA buffer may have like n triangles, triangle strips, and say a triangle basically again that's further divided into pixels. Pixel comprises of shader instructions, as you know. So so there's what I'm saying is there's a DMA buffer which is like the key unit of workload, and that has further granular primitives within itself, right? So in previous operating systems in Windows 7 and before, say if application B comes along, right, which is the second thing which you want to do, and application A was executing, right? Application B could only start executing when application A here finished the DMA buffer. So we were not able to stop application A in the middle of execution anywhere here, right? So say for example a primitive is over, you really want, okay, maybe my primitive is over, I can now give the GPU resource to application B as looks like it's got critical stuff to do, right? So in Windows 8, as you can see here, we enable that. So we on GPUs which are capable of preempting midstream between the DMA buffer, right, we can now stop the GPU and preempt the work in between like the DMA buffer, right? So and it really, where you can preempt and at what boundary you can preempt really depends on the capability of the GPU, right? So if your GPU has like really fine preemption capability, say for example if it can preempt on like a pixel boundary, then that's awesome, right? Because the finer the preemption, the better the responsiveness, right? If you can preempt at a DMA buffer boundary like you can do today, this is what you get today. And if you can preempt midstream, you're going to get finer and finer. So it's going to be much smoother. And that really helps a lot of these scenarios. And the key here is to, if you're a driver developer and a silicon vendor, is to get GPUs which do finer levels of preemption, right? As you heard in the last day and today, right? A lot of the work, almost everything now, the Metro style applications, the Metro UI are really dependent on the GPU. All of these, there's going to be way more applications which are going to be using GPU resources, and not like in Windows Vista and Windows 7 where you had like select number of games and few applications. Like pretty much the way we've architected the system, as you've seen yesterday, a lot of this really uses DX underneath, and which really uses WDDM as the driver model. So so if you're a system manufacturer, make sure you work with your GPU silicon vendor and get the GPUs which have really good finer levels of preemption. As the finer the preemption, the better the responsiveness, the better your Metro style applications are gonna respond and like look for the end user. So one of the things you've done is, like I said again, I'm kind of repeating myself, but like a lot of people will be using GPU and GPU memory and GPU resources. One of the things we've done is made available an API which makes it easy for applications to utilize GPU memory resources. That's what we call really video memory offer and reclaim. But the scenario here is, say you have on any particular device, for example, you have say 2 or 3 applications. All of these applications now, say if the Metro style applications, are using some amounts of video memory, right? On say small form factors, or form factors basically which have limited amounts of GPU video memory, there's little video memory to go around. So what you really want is to make sure that applications use video memory wisely, and to not use memory if you're not just really needing it. For a great example is like temporary resources, intermediate vertex buffers, and dynamic vertex buffers. So here the example is, say you launch a metro style application, right? So you launch the application, your application goes and allocates a bunch of resources. You'll allocate some memory resources. Some of them will be in video memory, for example. So then what you do is, when you allocate resources, or like say textures or like other for other things like surfaces. So what you do is you call offer API, and I mean you don't call it on every single thing. You don't call the offer API on things which you really need. You call it on things which it's okay to lose. So for example, resources which can be easily recreated. That is really the key. You call offer on the resources which can easily be recreated, such that if they go away, you can regenerate them, right? So what happens is, so your application does this, and say there's memory pressure, right? You go into the background, there's another application which gets launched, and there's a bunch of other applications get launched. All of them are going to need video memory now, right? So if there's memory pressure, what we'll do is we'll trim away the resources which have been offered. So it's great for other applications, so if other applications get video memory, and the system as a whole is again utilizes less video memory, utilizes less resources, is more responsive at the end of the day, right? So you do that, and if there's no memory pressure at all, then your resources are still around and you can use that. So that's one of the APIs we made available to metro style applications in DirectX. Actually, it's a DX API, and you can use that to get a good experience for utilizing memory resources in Windows 8. So at the end of the day, you have memory available to all applications, everything behaves well, and you have a great experience on the Windows 8 system. In fact, we have a sample in the SDK which shows how to use this API, and you can go through that. There's also a DDI for 1.2 drivers, because this is quite important for drivers also, which use a lot of intermediate surfaces, a lot of intermediate resources, staging surfaces, and so on. So the thing is, there's so many form factors, and the range of GPUs is so vast. We need to be cognizant of how much resources we use, and we need to use them wisely. So on this, another side point here, and the benefit actually is not only on systems which have low GPU resources. In fact, the benefit is also there on systems which have large amounts of video memory. So now what can happen is, if you have a system which has like say tons of GPU video memory, your application can freely allocate a lot of caches, a lot of intermediate surfaces to boost the performance, right? And you allocate all these caches and you mark them offer. Allocate a cache, mark them offer, right? So you can do this as long as you mark them offer, and you gain the performance as long as there is no memory pressure, right? So we have good performance as long as there is no pressure. If there is memory pressure, we'll take the resources away. So it's a great benefit for across the entire range of the form factors. Component, so power management, right? You saw the demo yesterday on idle power. So across all these form factors, especially the small form factors, right, like tablets, you switch it on, you switch it off. When it's on, you want it to utilize as little power. I mean, overall, right? I mean, it's not new. Battery life as such is like a really critical factor when users go to Best Buy or any other place and make a purchasing decision on their next PC, right? So with all these new form factors, it's even more critical to use less resources. So if my system is on, like similar to the phone, if I switch it off, I want to make sure it's not draining a lot of power in the off state. When my screen is off, it's just lying on my table anyway, right? Or if it's doing say a particular operation, I want to make sure the resources which are necessary only for that particular operation are being used, and not everything is on. So here, with respect to graphics and GPU, what we've done is, you can see a GPU here. It can be seen as having a number of components. It has a 3D engine, it's got a video engine, it's got a display controller, memory, and video engine. So say for example, I'm watching a YouTube video or any other, I'm watching a video, say for example, right? And the video is using just resources on my video engine, and it's using resources from my memory controller, right? So there's really it's not really using anything from my 3D engine, 2D engine, for example, and all of these by themselves consume individual amounts of power, which is quite significant, right? So what you really want is, say when I have that application full screen playing video, it should just keep this guys on, right? And really, I want this guys like 3D engine, 2D engine to go as in a low power state as much as possible, right? So basically, the bottom line is, if you can switch the other components at a finer level, you can turn them off, so even better, or like as little power, low power state as possible. The more battery life, the more power savings for everyone, right? So as you can see here, there's various component states. These are exposed through the driver DDI, and the GPU vendor basically informs us about these states, and it's enabled to tell us, okay, hey, I have like 2 states, there's on and off. Hey, if it's a display controller, I have a self-refreshing display controller. I can even go into self-refresh. So we get this description from these components, and you'll see in a connected standby talk and the power talks, there is a central component in the OS which is called the power plugin, for example, on SOC systems, which controls the power between devices, right? So there is like a central coordination of all the power between devices, and that component really manages when a device goes off, device goes on, and at every device level, the graphics stack, for example, in the case of GPU, manages and works with the other components to tell that, hey, I can turn my 3D engine off or 2D engine off. So it goes all the way between devices and through the device, deeper into the device. So video playback, right? What is the number one? An improvement which we did in Windows 8. In the past, what has happened is, if you're a video player ISV, you really had to, mix DX9 APIs and DX10 or DX11 APIs, right, for writing a video player. So what we've really done is you have now a unified API for all video ISV developers. It's a combined D3 11.1 API which you use, and you don't have like a separate set of APIs which you need to juggle and mix, right? It works great with Media Foundation. So basically the bottom line is a simple API. Should be much easier if you're writing a Metro style application to use this API and write your application. So there's other improvements, and actually with respect to Stereo 3D, we made available some hints and capabilities to Metro style applications for drivers actually, which are going to be Stereo 3D capable on Stereo 3D systems, such as the packing layouts and some common stereo formats such as row interleaved, column interleaved. So you can use them, and if they are depending on the display you have, and expose them through the driver. One of the third ones, direct flip, really I'll go into detail here. It's not only for video playback, but the value here is for any DirectX application. So in the past, if you remember, if you had a 3D game, most of these games, they want to utilize every single ounce of GPU horsepower there is, and what it really did is it went full screen exclusive, and there's no one else really using the GPU resource, and just made sure that it's utilizing the GPU horsepower to the best, right? And what it did basically was it's composing and it's directly presenting to the screen, right? So here direct flip basically is the same performance without being the exclusive for Metro style applications. So there's an API, direct flip API, which any DX application can use for flip sequentials really, but you can use that API, and you can present directly to the screen as seen here, right, instead of this flip here. This really is the application swap chain, and here which is shared with the desktop. So if you're a D-flip application, you switch directly here. So the performance is the same as you would get in a full screen application now, but the benefit now is if you remember the UI elements, you have your application really running in full screen, but at the same time, say for example, I want to share something, you swipe from the right on your tablet and you get the charms bar. So you need the UI to be available at all times, right? So that this gives the flexibility of being a full screen application and the Metro UI and the charm bar and other elements to be available at the same time without losing focus of the application, which happened to full screen DX applications in the past. This one here, like I said before, we worked with our ecosystem team and reached to potential engineering partners. When we saw basically when we were in the planning phase, there's a lot of GPUs which are now tile-based renderers as opposed to traditional immediate mode renderers. So given the popularity of this class of GPUs, which we worked with potential partners who had these GPUs, and we basically want to make sure your Metro style applications sizzle on TBR GPUs also, right? You get the same or better performance or on TBR GPUs. So we want to make sure that happened. So we worked with partners, and we really have an end-to-end kind of API and right down to the DDI in the form of hints, in the form of capabilities, in the form of DDI, which tells that this is a TBR GPU, and tells the application that these are the hints. You want to do this because this is the kind of GPU you have, for example. So there's several optimizations which went in the DX stack. We have Max here, who was responsible for a lot of these optimizations. If you have further questions, then we can. Yeah, so we did that work's gone in again for improving the performance of all form factors, anyone who's using TBR GPUs. Reliability. So like I said, right, I mean, you have all these clients, all Metro style applications, going to be using the GPU. It's way more clients now than ever before. The UI itself is going to be using the GPU here. So we invested quite heavily in GPU fault tolerance, and some of you might know this as what we call TDR, or timeout detection and recovery. That's really the technical lingo what we use. So here what I have here is, for example, I'll walk you through the scenario in a bit, but shows really the improvement what we made in GPU fault tolerance. And the benefit here is really for your Metro style application, which will say, for example, if there's a misbehaving application here, in this case, say application C, right? In the past, what happened is if say application C is misbehaving and it results in a GPU hang, it takes down all these applications along with it, right? So say your Metro style application A, B, and D, all these guys are gone. They get device loss. The reset mechanism is like global. It's GPU wide, right? So all the applications get device lost, and we reset and recover the entire system, which is what TDR is. In Windows 8, what we have done is we've isolated this application. So for example, now if application C is your misbehaving application and it's misbehaving on the video engine, only the applications which are currently queued on or running on the video engine are the ones which are affected, right? So your Metro style application here, A or B or D, which is say running on the 3D engine just fine, is not affected at all. It continues to be running, it's unaffected, it should be fine, right? So it's basically what we call per engine TDR. So only the particular engine of the GPU is the one which is affected, and so your other applications which are using the other engines stay running fine. Another benefit really here is in terms of compute applications. So in the past, also what used to happen is, say if you have a compute application and it's just running on running on the GPU on like a server, for example, and there's no one else utilizing any GPU resources, right? And say if it's running and it's taking more than 2 seconds for like a really long command to execute, we used to still call timeout. Hey, it's more than the allocated time. You got to timeout, and if it didn't respond back, we TDR. So now what happens is we've enabled these class of long-running compute applications to run as long as possible, as long as they're running fine, and there is no one else waiting on the GPU, right? That is really the key. As long as there's no one else waiting on the GPU, you can keep running on the GPU as long as you're live. So that's another scenario which gets enabled through our fault tolerance improvements which we've done in Windows 8. So let's recap really what we've gone through. Like I said, The overall, like the two terms which you've heard a lot, I'm sure already, is like really fast and fluid. And you can see, if you remember the chart in the beginning of my presentation, a lot of the improvements like reliability, a lot of the improvements around performance, and also end user experience, right? All of them really kind of relate to the overarching goal of the system and your metro style application being really responsive, really fast and fluid, seamless, and things flowing smoothly throughout your system, right? So we've done a bunch of improvements there. There's a white paper, like I said, which has the exhaustive list of all 1.2 features, which I encourage you to download and read if you're interested in the features there. And make sure you use the hardware certification kit. There's a talk by Rudolf Balas. It's on Thursday. It's called Graphics Hardware Certification. The number is 215. So thank you. So he's going to go into detail into how, if you're a system manufacturer, how are you enabled with all our new tools and this new experience, and what are the things you should like really watch out for, and make all these applications like rock on a Windows 8 system, right? And what I've done in the talk, if you notice, is basically I've gone over some of the key experiences and improvements in the graphics driver model. There's also a part of the talk for the graphics driver model. Remember in one of the first slides when I said XPDM is deprecated, it's been removed. At the same time, we just didn't do that, right? We just didn't yank out the code. Of course, we want to make sure the customers who are using XPDM, they have their scenarios which can be migrated over, which can be ported. There is an alternative solution for those guys. And Akshay is going to talk about graphics and server, because a lot of them are server scenarios. And there's also a chalk talk on migrating from XPDM to WDDM, which Akshay and Roger are going to do on Thursday. So I'll encourage you guys to attend those. So here really the number of sessions which I put together, which I thought would be interesting and related to this talk. And there's a link to the white paper, should be on Microsoft.com, should be live. Then there's a D311 documentation, which also goes along with a number of things, like I said, and samples. There's like a number of samples. In fact, a lot of our graphics team members have written metro style applications like native DX samples, which should be available to you. You can see some of these things like rotation API and video memory offer. You can see, and stereo 3D, for example, just small and neat samples which show how to use this API. All right, cool. Thing one time. And we have several members of our team, if you have any questions, feel free to ask. We'll be available in the booths, in the platform booth number 2. A bunch of us will be hanging around there. If you have more questions, if you have need more details about something particular thing here, we'll be around. All right.